Hello and welcome, dear friends. So today we are going to discuss the implementation or the case studies for the lectures, theoretical frameworks, theoretical lectures which we have discussed in week 8 and 9. That is, we are going to calculate the returns of a stock prices. Then we are going to form a portfolio and find out the mean variance and covariance of those portfolio. Then also we are going to estimate the CAPM beta, that is the CAPM model. Then we are also going to estimate the arbitrage price theory model, and at the end we are going to test the efficient market hypothesis. So in the today's lecture is basically all those what we have discussed in the week 8 and 9. We are going to see how we can use those theoretical models for the Indian data and implement those models using R. So again we are following the similar approach here. We will have the R project, and within that R project we have the script file where all the functions which we are going to use is there, and we'll execute and we'll see the results and try to interpret those various results here. So this is the project folder we have, and in that here we have the R script folder, that is the case studies week 8 and 9 here. Now let us click on that. So once we click on that, here we are having this particular option here. Let us first clean the data here, environment. So I'm clicking those. Now again here we are getting the message there are the two packages which is not installed into this machine. So let us first install those here. So we have installed those packages. Now let us take one by one. So these are the various packages we are going to use into this lecture or hands-on. First we are going to use the quant mode, then performance analytics package, tidyverse, T-series, ggplot2, grid extra, read excel, lm test, and car. These are the various packages we are going to use. Now every package has to be attached to this particular session here. So we can select all those and we can run here. Now every package has been attached to here. Now first thing what we'll do, we'll import the data. So we are directly importing the data from the internet using the Yahoo Finance, source Yahoo Finance. That means we have to have the internet connection here. So for that, TICAS basically on the Yahoo Finance, these are the nomenclature they have through which we give the reference those and we take that. This here Reliance is the basically for the Reliance company. .ns basically shows listed on the National Stock Exchange rather than on the Bombay Stock Exchange. So we are taking the three stock prices: Reliance, TCS, and Infosys. So let us create the first object of TICAS here. So now you can observe here this object has been created here. Once we create it, now we are downloading the data from the Yahoo Finance. For that we use the get symbols from the quant mode, then giving which variables are going to download. So the ticker here we have already installed, saved that object, so we are getting the reference of that object. Then from date to source is Yahoo. So let us download. So once we download, so these are the data here we are getting: Infosys, Reliance, and TCS, and all these are the daily data we have. So let us see here, observe here. So here what we have: open, high, low, and close. So open means the opening price, high means the high for that particular day, low means low for the particular day, close means closing price of that day. This is the volume we have, and here we have the adjusted prices here also. So that's the basically we have taken. Now what we are doing, we are preparing the data to be used for the estimation. So first thing, because it's the price data, and we have already discussed in the theoretical lectures that we do not use the price data, rather than we prefer to use the return data. So here we are creating a return data. So first thing, we are using NA omit. NA omit, if there is any missing number, skip that. Then the second, we are using merge. So basically here we have the individual series, we are merging all those series here. Then closing. So in every file you can see there are the six variables we have, but we are going to use only closing price. So we are giving the reference of the closing price. So let us calculate that here. So we have calculated here. So you can see here we have the return data now here. Daily returns 1, daily returns 2. So we do not know which one column is which. However, we have the reference that the first column was about the Reliance, second column was about the TCS, third column was Infosys. Therefore, we are now changing the name, column names, Reliance, TCS and Infosys. So let us run here. So once we run here, now we can observe here what we have: Reliance, TCS, Infosys, rather than having return 1, return 2, return 3. Now, once we calculated the return, now we are going to calculate the portfolio. So how to calculate the portfolio? First, we have to assign the weight. That means how much of the total money is going to be invested into the Reliance, TCS and Infosys. So here we have given the 3 weights. If we have 4 stock prices, 4 assets, we have to give the 4 weightage. And all that weightage must be equal to the 1. So let us say here we have weight. Now we are calculating the portfolio returns. How to calculate the portfolio returns? We know that the portfolio return is being calculated from the theoretical literature. We know the portfolio return. How we calculate the portfolio return? RT is nothing but W1 R1 plus W2 R2 plus so on plus WN RR. So that is basically weighted sum, weighted average we have the portfolio. So that's what we are going here. So the portfolio return, we use the return portfolio function, then we are giving the reference of the returns, those series, and what is the weight. Here we are giving that weight. So this is the portfolio return we have created. So here we can see here the one column we got the portfolio return of this, which is basically nothing but the weighted sum we have of the returns now. Then now we are going to calculate the portfolio matrix. That means we are going to calculate the mean, variance and standard deviation of the portfolio. So the portfolio mean is nothing, the function mean of that reference here. So mean, similarly we have calculated the variance and standard deviation here. Now let us take the print of all here. Now let us see the result here. So we can see the portfolio mean is 0.00755. Portfolio variance is here 0.0021374888 and the standard deviation is 0.0146. So that's the basically we have the results here. Now let us visualize the returns. So here to visualize the returns, first what we do, we are going to use the package ggplot2. Now what we have stored, we have stored our data into the STX format or the JU format. So this is the basically for the time series data we are using. However, if you wanted to use the ggplot package, the early function from the ggplot package, we have to convert this into the data frame. So for that what we use the function fortify dot do, then we give the reference of the data file. Then it will convert the data file from XTS or JU to data frame. And here now we can use the ggplot to functions. So that's what we are going to do here. So first we are creating the plot data, basically converting the data from gg data frame. So this, now we can see here plot data we have like this, 4 variable. One is index, Reliance, TCS and Infosys. Now let us first plot the Reliance log here. So plot ggplot is the function name from the package ggplot, the reference of data. A is basically aesthetics we have, that is x-axis will be index, y-axis will be the Reliance, that column. Now this labs geom line, basically we are plotting a line plot. So color of that line plot should be blue, size means width of that should be equal to 1. Then again plus labs, that means labels. The main title should be log returns of the Reliance. X-axis title will be time, y-axis title will be value. Theme is minimal. So let us plot this. We have plotted this and stored it into the plot 1. Similarly, we are going to plot here for the TCS and third plot for the Infosys. Now, using the grid arrange from the package grid extra, now what is plot 1, plot 2, plot 3, number of columns 1. So, one by other it will be stacked here. So, let us run here. So, once we run here, so we can see the plots here. So, this is the log returns of the Reliance, this is the log returns of the TCS, and this is the log return of Infosys. From this, there are many certain observations we can observe. So, for example, we are seeing the volatility clustering effect here. Then we can see that the mean, it is basically stationary series. So, by looking all those things, we can get the information. Now, once we done, let us also plot the market portfolio. So, here is the portfolio return which we have basically created. So, this is the return of the portfolio, how it is observing. Now, let us first calculate the beta, CAPM, that is capital asset pricing model beta. What it says? Capital asset pricing model basically says this, that any asset return will be the function of the market return, and here we have alpha 0 plus beta and the market return plus u. So this is beta is nothing but CAPM beta we call, and this is nothing but the capital asset pricing model is tell. So this CAPM beta basically so the sensitivity of stock returns or any asset returns to the market return. So if there is change overall market, there will be change into the stock return. So that's what we are saying here. So for that, first we have to find out what is the market return. So basically Nifty 50, we are assuming that reflects the market return. So we get the download the data of Nifty 50. So then we calculate the market return. Now we align the market return and this, because there might be some mismatch into the missing observation. So we are basically aligning that. So now all the missing observation is over. Now aligned return, basically they have all the 4 returns have the same number of observations. Now market return we are calculating here. Then the function we are creating here, the function is basically market return, covariance of stock returns into the market returns divided by variance of market return. You might recall that the CAPM beta is basically nothing but the covariance between the stock return and the market return divided by the variance of market return. So this is the formula we are going to use to estimate the CAPM beta here. So for that we have created a function whose name is beta. That function is stock returns and the market returns, and what they have to find out, they have to find out covariance between stock returns and market returns divided by variance of market returns. So the beta is the function which we have created, and that basically creates this. Now to calculate the beta, what we have done, betas S apply, that means in all the columns we are applying from 1 to column aligned returns for all the columns, minus 1 function I beta aligned returns I aligned market return. So basically we are using this function to calculate the beta of all those three. So why we have minus 1 here? Because number of columns at the last we have market return, so that we cannot use here. So therefore we have minus 1 here, number of column minus 1. Now if we execute here, so we have calculated the beta. Now this is the individual beta. Now what will be the portfolio beta? Again, portfolio beta is nothing but what we have weighted betas. So let us calculate the portfolio beta here. So let us calculate the aligned market returns. Now we have calculated the portfolio beta. Let us display the portfolio beta and the individual beta here. Now what we can observe here, individual beta, Reliance is 1.098, TCS is 0.76 and Infosys is 0.915. What does it reflect? It reflects that if the market return is increasing or decreasing, there will be more than proportionate change into the Reliance. However, the TCS, it follows 76% and Infosys is 0.97, and here the portfolio beta is basically this here. So what basically it suggests us this. Now if you look at here, what we have this, the Reliance beta. So basically what we say, the return of the Reliance is here alpha 0 plus beta and the market return here. Here the market return is nothing but the Nifty 50. So we have got the value of beta here. So that means now the beta for the Reliance is 1.098. That means if there is 1% change into the Nifty 50, the Reliance will be changing by 1.098%. So if there is the positive change, the Reliance will have the higher advantage. On the other hand, the TCS, for the TCS beta, what we have 0.76. That means if the Nifty 50 is changing by, let us say, 1%, then TCS will change by 0.76%, and similarly goes with the Infosys. Now if you see the portfolio beta, what we have 0.94. In essence, let us say if there is a negative return, so highly correlated with the market. However, when I are combining those assets, we are able to minimize this value beta head. That means we have diversified this risk here. Now, so that is the one way to calculate. Another way to calculate the beta is basically using the function CAPM beta. CAPM beta is the function from the performance analytics. So here we are calculating individual beta, S apply return, function stock return, CAPM beta, stock returns and market. So here now using the CAPM beta for all the individual. So here let us say we are calculating beta Reliance, CAPM beta return, the stock return and the market return. So we are calculating beta return. Similarly, we are calculating beta for the TCS, we are calculating beta for the Infosys, and we are combining all those into one individual beta by using the cbind function. Then we are also calculating portfolio return and portfolio beta using the CAPM function, portfolio and market return. Now let us say we are displaying all those here. So you can see the similar result we got, however we have used the different methods. There is the marginal difference will be there. Now in this case what we have assumed here, that the basically we have assumed risk-free rate return is 0. Otherwise actual model of the CAPM is that RT minus risk-free rate plus alpha 0 plus beta 0 beta 1 then RF market return minus RF plus U. However, in such cases we have assumed the value of RF is equal to 0. Now let us say if we are not assuming RF is equal to 0, then we can use this particular case here. For that I am importing a data where we have the data of, so let us import the data here. So we are importing this C data. So if we observe the C data, what we have Nifty 50, wholesale price index, then we have treasury bill rate, that is 91 days treasury bill rate, we have government securities, TCS and oil price. This treasury bill rate is basically we will be using as a proxy for the risk-free rate. Why the treasury bill is always used as the risk-free rate? Because it is backed by the government and there is no as such any risk associated we have. So that's why 91 days treasury bill rate is being used as the proxy for the risk-free rate. Now once we have done, first we are calculating the return of those data here. So then here I am deducting minus 1. Basically why we are doing that? So once we calculate the return, that is our data, you can see because we have taken the lag, so there is one missing observation. If there is the missing observations, we cannot use those different models. So to remove that, what we have minus 1 comma all. So basically we are deleting the first observation using this function. So now here we can see no more missing observation we have. Once we prepare the data, then we are basically calculating the difference between the asset returns and the risk-free rate and the market return and the risk-free rate. So here the treasury bill rate has been divided by 12 because it is a monthly data we have taken. So this we have done. So the TCS, so basically this is nothing but the return minus the risk-free rate. For the market we are also doing the same. Now let us plot this data. So this is the basically what we have TCS and the Nifty 50 here. It seems a correlation. So let us calculate the CAPM beta now using the regression model. So we are using the LM, which already we have discussed earlier. This is the data is basically dependent variable and this is the Nifty 50 market return. So let us calculate this here. So here we have the summary. In this summary, what we can observe, yes, the Nifty 50 is the significant. That means it has this beta is significant and the value of beta is 0.640657. And this shows there is the significant impact we have of this beta. Now we can test the certain hypothesis. For example, linear hypothesis we can test, or all those hypothesis diagnostic tests we can perform, which we have discussed in the linear regression model. Now moving to the arbitrage pricing theory. What is the arbitrage pricing theory says? Arbitrage pricing theory says that there is not only the market return, there are the many other factors which do have impact on the asset return. So that's what we are going to discuss here. So first model, L apply stock functions, basically here the market interest rate. So basically here we are going to fit the model using the LM. So our data the TCS and the Nifty 50, and we have also added the inflation, we have also added the oil price. So that's nothing but the structure of arbitrage pricing theory model we have. So let us take the summary of this model. Again, if you are taking the summary of this model, so what we can observe, only the Nifty 50 is effective, the others are not significant. That means the market model is sufficient, or the CAPM model is sufficient to explain the movement into the stock returns of the TCS rather than any other factors here. So again, all other diagnostic tests can be conducted, which we have conducted into the linear regression model. Now moving to us to the testing the market efficiency hypothesis. In the market efficiency hypothesis, basically what we are using the ADF. So aim is test, apply, return. We are using the function ADF test here. So let us this. So what is the ADF test says? So basically in the efficient market hypothesis, what is the hypothesis we have? That price of today should not be the function of price of previous. Why? Because the efficient market hypothesis says that any price has all the informations. It should reflect all the informations available with the public. If that is the case, then this price should not depend on the previous. If that is the case, that means that we'll use the unit root test to test that. What unit root test says that if there is what we have yt is equal to alpha 0 plus beta or phi yt minus 1. If the phi is less than 0, then it is stationary. If phi is not equal to 0, then there should not be any significance. So if you are using the unit root test, so here we are getting the every variable is showing that it is stationary. If it is stationary, that means the value of phi is less than 1. That means there is the dependency of the current price with the previous prices. That means there is the market efficient market hypothesis is not validated in this particular case. So that's how all we have discussed for the theories, and here we have discussed the calculation of the return, how we calculate the portfolio, construct the portfolio, how we calculate the variance standard deviation of the portfolio and the mean return of the portfolio, then how we calculate the beta, which basically shows the sensitivity of any asset return with the market performance. Then we have also discussed the arbitrage price theory, where basically we assume that it's not the only market, there are the many other factors which might have effect on the stock returns. Then we have tested the efficient market hypothesis. So that's all for this lecture today. Thank you so much.